Okay, so
Good afternoon, students. Hello. Good afternoon. Just checking to make sure everybody can hear me.
Afternoon, sir.
Afternoon, sir.
All right, good. All right. So it's more of vectors today. So because of what happened, we basically sort of changed the plans a little bit. So we're gonna actually have the class activity Sunday, Monday, and class work Wednesday, Thursday next week. All right. So what it is that we're going to be practicing some more vectors questions. And I know expect that question that are sent in the group, expect persons now to go and attempt and do that question. All right, after this session. You should be able to do that question now. All right, so the question on the paper is from June 2010. We're just doing some more past paper questions. This one is from June 2010. As you can see here, it's the number 11 question on the paper. At that time, there were 11 questions on the exam paper. Your syllabus now is 10 questions you see on the exam paper. And this is the vectors question right here, part B. All right, so let's look at it. So it gives us this diagram. It's a triangle, JKL. And it tells us that M and N are points on JK and JL. So M is on JK, that's on this side, and N is on JL, that's on this side, such that the JM is 1/3 of the entire line, 1/3, and the JN is also 1/3 of this line. So we're going to position those points. You see, they want us to copy the diagram and insert the points M and N on the diagram. So if I zoom it up, 1/3. So it's like we divide the line in 3 equal parts. Similarly here, it's like we divide it in 3 equal parts. And this is where the M would be on that line, and this is where the N would be on this line. And so this side here has 1 part, and here has 2 parts. So this is 2/3 of the line. This is 1/3 of the line. Similarly, on this side, this is 1/3 of the line having 1 part, and this is 2/3 of the line having 2 parts. Let me move these marks now. All right. All right. So those are the positions. All right. So this is 1/3. Sorry. 1/3, 2/3, 1/3, 2/3. All right. Then the question tells us that JM is the vector U and JN is the vector V. Let's put them on the diagram. So Jn, Jm is U, Jm, that's this one, is U, and this one is V. All right, so let's put them on the diagram here now. All right, so this vector is V. Let me move this. This vector from here to here is VRU. The first one is U, U. And the vector here is V. So if this is one part of the line that is U, what is this vector up here? What is this vector from M to K? Mute your mic, please. Mute your mic. What is that vector from M to K? Somebody tell me. What will be that vector? If this vector here, from here to here, is U, and it is one part of the line where this is two part, 2U. Simple as that, 2U. And then so similarly, since here is V, then the part from here to here is 2V. I want to fill out the vector diagram with as much information as I can. All right. So I've done that. So this question now is asking us for JK. So if you look at the diagram, we want to go from J to K. That is clearly 3U. U plus 2U is 3U. So this is just 3U. So this answer is 3U. And then they want Mn. So look at it to go from M to N. So that we come back here and then go there. That is the movement. So we go minus U. We go minus U here plus V. Minus U plus V using the diagram. So this will be minus U plus V, which basically is the same as V minus U. If you turn them around, same as V minus U. All right, to go from M to N. And then they want KL. Look at the diagram again. To go from K to L. It's like to come down this 3U this way, minus 3U, and then go 3V this way, 3V. Go from K to L. So it's minus 3U plus 3V. All right, so this would be equal to minus 3U plus 3V, which again can be written as 3V minus 3U. 3V minus 3U. All right, that is that. Then here now says we are to, using the findings in B2, using the findings here, we are to deduce two geometric relationships between KL and MN. And this relates to the line KL, and this relates to the line MN. And so we'll compare these two vectors. And generally speaking, when they ask you for two relationship between two lines, as I told you yesterday, the answer is going to be that they are parallel, and then the other relationship is how long one is more than the next one. Right? And you can see clearly here that is a 3 times relationship we have. Right? So let's write them down over here. The KL or the MN first is the vector V minus U from here. And the KL vector, it is 3V minus 3U. And they are parallel. We want to show that they are parallel. To show that they are parallel, you have to be able to show that one is a multiple of the next. So if you follow the process, this is the smaller one, V minus U, or this is 3V minus 3U. You want this to become equal to this. So what you would do, you would multiply this one by 3, multiply up the small one to make it equal the large one. So we'll multiply this one by 3. And then you multiply this by 3, then we would get that 3mn is now equal to 3v minus 3u. And so this and this would now be the same, and therefore this and this will be equal. And so we can draw the conclusion by equating the two of them. We're going to equate. And when we equate, we put in this equals this. Or we can put it the other way, this equals that. So we can put the KL equals the 3mn. So they want two relationships because one is a multiple of the next. You know that they are parallel. One, they are parallel. First relationship is that they are parallel. KL is parallel to MN. In addition to that, KL is 3 times the length of MN because if you take the modulus of both sides, you will get that KL equals 3mn in length, right? That is talking about the length of the lines. We can see it in the vector equation as well. You can even see it on the diagram that this line, KL, is 3 times as long as this one. They're parallel enough, but this one is 3 times as long as that. That's what these numbers mean, right over here. And so we can write that as our second relationship. Second relationship is relating to the length. So KL is 3 times the length of MN. KL is 3 times MN in length. That's it, two relationships. Anytime you're doing a vectors question at this level, and they ask for two relationships, believe me, one of them is going to be that they are parallel, but you have to show that they are parallel, so you have to get this equation still. And then now, you also got to have a relationship relating to the length of the lines, or the ratio of the lines. All right, so that is the answer for that one. But go to that. Any questions?
Yes, sir. We're good, man.
Very good. All right, so that finishes that question. So that's 2010. Let's work upwards today. We're going to go to 2011. 2011. So that means that we're going to be doing the January exam papers on Saturday. All right, so we're focusing on the June ones now. All right, so let's find that question. I'm going to go over this side, 2011. All right, 2011, again, usually at the back. The vectors question is at the back. All right, here we go. Like this question. A parallelogram question now. All right, like this question. One of the classwork is going to be similar to this. I can tell you from now. So we're doing this question now. Part B. All right, that question. All right, let's look at it. So the question says, WXYV is a parallelogram. So this is a parallelogram. It says Vy is A. The vector Vy is this small a here. And the vector VW up here is B, this B right here. But because this is a parallelogram, I'm going to fill out right away that this vector across here is equal to this one. So when I put that on it right away, that this vector up here is also A. And this one equal and parallel. And so the vector over here is also B. So I'm going to put it on it from now. The vector up here is B. Because it's a parallelogram. So the opposite sides are equal in length and parallel. So they are equal vectors. The opposite sides here are also equal in length and parallel. So they are parallel vectors. Then the question tells us that S is on WY. S is on WY, which is this side. You can see the S right here. such that WS to SY is 1 to 2. Now, how am I going to deal with that? I'm going to put the ratio that they gave me on the line so I can see the parts. So the WS is 1 part, and the SY is 2 parts, The SY is 2 parts, not the 2 here. So the total parts on the line is 3. So I mean that this piece right here is actually 2/3 of the whole line WY. And this part right here is 1/3 of the whole line WY. Right? That's what this ratio presents to us, this ratio. And I do it by putting the ratio values on the line. So the total parts is 3, 1 plus 2 is 3. This is 1 out of the 3. This is 2 out of the 3. I'm talking about of the entire line. And based on that, I can proceed. Question wants me first to calculate the vector WY. So how do I go from W to Y? Look at the diagram, there's a different color for that. To go from W to Y, going from here to here, I have to go along these vector directions that I know. Go from W to Y. 2 ways I can do it. I can come minus B plus A. I can go the other direction by going this way first with an A and then come minus a B. So it will be A minus B. But can I say that? I'm going to write that A minus B. So I go from W to X and then X to Y. So I can actually write that I go from W to X and then X to Y. The W to X is A and the X to Y is negative B. Okay, going in the opposite direction. That's it. The next part wants WS. WS is this little piece right here. I told you that all vectors question set is that a lot of the time what you find here is used to find there. And then these now can be used to find here. It's usually that sequential in terms of the order of solving the question. So now we want to calculate WS, which is this little piece right here, WS. Somebody can tell me we're going to get WS, what WS is equal to? Huh? 1/3, right? This WS is now 1/3 of the entire WY. That's how we have to put. So this is 1/3 of the WY. And this is the WY. And so it becomes 1/3 of this, 1/3 of that. And so there's 1/3 each part. So it becomes 1/3 the A, and 1/3 that becomes minus 1/3 of the B. But okay with that?
Yes, sir.
Okay. And the last part now wants us to calculate SX, to go from S to X. Somebody tell me how can I go from S to X?
Sir. Oh. We're going to do minus 2/3 of.
No, tell me in terms of the letters first. So as I wrote out this one and I wrote out this one, tell me how I'm gonna go from S to X, from S to X. Tell me the points that I'm gonna go first. Where to where, and then where to where. Think of vectors that way. How can I go from S to X? Remember, I now know this vector down here now because I have it, WY. So talk to me now. How can I go from S to X? Tell me.
Sir, could I use S to Y?
S to Y.
Yeah, and then from Y to X.
And then Y to X. Good. All right. Let me do this question. Let me do this part over here because we need to do a little bit more, right? So let me do it over here. That's good. So he's saying that to go from S to X, it could go S to Y, and then we could go Y to X. All right, after me now. What is the SX equal to? This piece.
Minus 2/3 of WY.
Y minus. WY is this way, no?
Sir, because.
And SX is the same way. WY is this way. And SX is the same way. So come again. Think again. Look,
Oh, 2/3 of
Sx
W.
is this 2/3 of Wy. Yes. This piece down here is 2/3 of the whole of that. Good. So the Sx that we want right here is really 2/3 of the Wy. And you're adding back the Yx. But we know Yx, and Yx is just this B. So we don't have to change anything. Yx is just the B. So no problem. Equals. Then 2/3 of Wy now really mean that we're calculating 2/3 of this. Remember, this is Wy now. So it's 2/3 of that. So it becomes 2/3 of the A and 2/3 of the minus B. So it becomes 2/3 A minus 2/3 B. And you're adding this Yx now, which is the B, Yx. So you're adding the B now. And so you want to consolidate these two. So it becomes 2/3 A. And then now, this is the same as 3/3B, this one. And then the 3 minus 2 give me 1. 3 minus 2 is 1, so it becomes 1/3B. So this becomes plus 1/3B. And then we can test if this answer makes sense to go from S to X. We can test if it makes sense. Let's test it in purple. So I'm saying, this is saying go 2/3 in the direction of A. Now remember, anything this full length is a full A now. Starting at S, we're coming 1/3 of A. No, 2/3 of A. If we had all of this, that would be a full A. But they don't want a full A, they don't want 2/3. This look like 2/3 of A to here. And then we're coming up here now, which is 1/3 of the B. A whole B will be all of this. We don't want a whole B, we only want this little piece of 1/3. So this answer looks correct. This looks like a 2/3 of A. And this looks like a 1/3 of B. So I can accept this answer based on what my diagram is showing me. But I appreciate that. But I go to that. But okay with that?
Yes, sir.
Yes, sir.
Yes.
All right. Anybody can tell me another way we could calculate Sx? Look at the diagram. Is there another way we calculate Sx? Is there another way we could go from S to X?
Yes, sir.
Tell me, and let's work it out. You're supposed to get the same answer. Sx. Tell me another way to go from S to X. So if you saw another way, you're supposed to give it the same answer.
WX.
Come again?
SWWX.
Good. We could go from S to W and then go from W to X. Good. So the question now is, what is the SW? What is the SW?
Minus
SW.
1/3.
Good. It is the minus WS that we found here, because we found WS this way, but now we are using SW going in the opposite way, this way. So it's basically the negative of this. So let's write it this way. So we are going to say that the SW really is minus WS. How we know WS? And we're adding back the WX. The WX is just the A up here now. WX. And the minus WS means that we're now going to put the negative on this. We're going to put the negative on that. That's what the minus WS is going to be. All right? So we put the negative on this part, it becomes minus 1/3. It becomes minus 1/3 A. So we're going to get minus 1/3 A. And put the negative on this, it becomes plus 1/3 B. Plus 1/3 B. And then now you're adding back this WX. The WX up here, so it's just A. A. So you're adding back the A. And so we're now consolidating these two A values. All right, let's underline them. The B's and the A's. So this 1/3 B remain as it is. But this A now is the same as 3/3. Let's put 3/3 on it. So then it is like I saying 3 minus 1. 3 minus 1 is 2. So it comes down to become 2/3A and then this 1/3 b comes back here. It's the only b term there. So you get plus 1/3 b. So you see we get the same answer, 2/3 a plus 1/3 b. But I go to that?
Yes, sir.
All right, so it could go either way. All right, let's look at the sugar part of the question now. The sugar part of the question says that R is the midpoint of VW. So R is the midpoint of this side, VW. We have to prove that R, S, and X are collinear, meaning they are on a straight line. So let's put it on the diagram. I'm going to put the point R on the diagram. All right, so I'm going to put it on the diagram. So what it means is that it's somewhere in the middle of this line, right? So I'm going to erase that B. I'm going to erase that B. And I'm going to erase this arrow. And I'm going to put a point right in the middle there. Let's put it down in blue. Right in the middle here, that is, and that is going to be my point R. Well, that is R. Remember, the entire vector was B, was B, So let's put on back some vectors now. If the entire thing was B, and I put in this midpoint, then what is the vector from V to R right here? Equal to, what is this?
Half B.
Half of B. And what is the vector from R to W right here? Right here. What is that
Half
vector?
B.
Half of B as well. Half of B. Good. And the 3 points that are collinear would be on a straight line here like this. Let me put it in blue. 3 points are collinear, put it in purple or in green. These 3 points they say are collinear. So if I just make a simple little sketch, it's supposed to look collinear for real, which it does. Looks like they are in fact on a straight line. So remember now, to show that 3 points are on a straight line, there are 2 things you have to do. You have to show that between the 3 points, you have 2 parallel vectors. And if you have 2 parallel vectors between 3 points, it means that you will also have a common point. That's what you have to prove, that you have parallel vectors with a common point. So you need to have 2 vectors between these 3 common points, between these 3 points, 2 vectors. So let's look at it now. So the next part, we're doing R, S, and X. R, S, and X. We are showing that they are collinear. We need to use 2 vectors. So what you're going to do, you're going to look and see if you have any yet. So this was the vector Sx. Now look and see if you have any yet that you can use. See, Sx. So we actually have 1 vector that we can use already. You only need any 2 vectors. So we're going to use Sx since we have it already. But since we just introduced the point R, it means that we're going to need either Rs or we're going to need Rx. But let's write down Sx first as a vector that we're going to use, this one. So we know we're going to be using Sx. Is 2/3 A plus 1/3 B. That's Sx. And the next vector we're going to use now, nobody can tell me which vector they would use. Nobody can tell me which vector they would use.
Sir, repeat the question.
I'm saying we need to use 2 vectors between these 3 points now to show that they are collinear. We have to use 2 vectors, show that those 2 vectors are parallel. And if you have 2 vectors between 3 points that are parallel, then one of the points will be a common point. And once you have parallel vectors with a common point, it means that the points are collinear. So I want to tell me which other vector we're going to use. We're saying we're going to use Sx. Since we have this already, it makes sense to use this one, Sx. So we're using the vector between these 2 points already. We need to use another vector including the R. So it's either we're going to be using Rs or we're going to be using Rx. So tell me which one you think is easier to use, the Rs or the Rx? Which one is easier to find? We had a similar situation yesterday. Which one?
Sir, Rx, because we already know the points.
Good. Rx is easier because I know you're just going half B plus A. See that? You don't have to calculate anything. If you're going to use Rx, right, Rs right here, You're gonna have to calculate because you're gonna have to say you go here and then go here. So you're gonna have to calculate. But if you're doing R X, then no calculation needed. You have the R, B, and you have the A. Simple as that. So we're gonna use RX. So we're gonna use RX. Very good. So we're gonna use RX. And Rx based on the diagram is gonna be half B plus A. Half B plus A out here. Gotta go to that?
Yes,
Yes.
sir.
And so we just need to show
Yes.
that these two vectors now are parallel. These two vectors, we need to show that they are parallel. And clearly, the X is gonna be the common point. So we need to go to the 3 steps process now to show that they are parallel. So somebody tell me now what are the 3 steps to show that they are parallel. Where is it? The 3 steps to show that those two vectors are parallel. What we're gonna do?
Third, turn it into
Get rid of the
get rid of
fractions.
Get
Get
rid
rid
of
of
the
the
fractions.
fractions.
Get rid of the fractions. Good. Get rid of the fractions. Now note that this has the A first and this has the B second, while this one has the B first and the A second. But that's all right, right? You want to make these two sides become equal. So how do we get rid of the fractions out of this one? What do we do?
find the low.
Find the LCM of
Yeah.
the
Right, which is what? This is 3 and this is 3. So we're gonna multiply it by 3. Let's multiply it by 3. It's clearly 3. Multiply it by 3, get rid of this fraction and get rid of this fraction. Remember to multiply this by the 3 as well, right? So multiply that one by 3. Multiply this by 3 first. We're gonna get 3 SX equals multiply this one by 3 to cancel the 3 on the here and gives us 2A. Multiply this one by 3, we're just gonna cancel the 3 on the here and give us 1B or just B. Good. This one now, want to get rid of the fraction of that one. What do we do with it? What do we get rid of the fraction? Times it by what?
times it by
Chips
Times by 2.
By 2. Beautiful. So we times that one by 2. We times this by the 2 first. We're gonna get 2Rx equals times this by the 2. We're gonna get B. Times this by the 2. We're gonna get 2A. Can you see that this and this is the same now? Just that they are written the other way around.
Yes, sir.
2A plus B, same as 2A plus B right here. Right? So now they are equal. So we don't have to multiply up any of them. So it means then that this equals this. And two things are equal because they are equaling the same thing. B plus 2A. But I can appreciate that.
Yes, sir.
Yes, sir.
So we reach a stage now where we can equate. No more adjustment needed. So we're going to equate. And when we equate, this will be equal to this because the two of them equal the same thing. 2A plus B. All right. So we're going to equate those two things. And we're going to write that 3SX is equal to 2RX. And that's it. One vector is a multiple of the next vector. But if we want, we can divide by the 3 and put 2/3 in it. We can write SX equals 2/3 RX. We could leave this and work with that still, it doesn't matter. Once you get one vector equals something times the next vector, that's it. But this is okay as well. Put on the arrow, same thing. SX is 2/3 of RX. Now, this now means that they are parallel and you also have a common point, which is X. And you have to state those two things. So the first thing you have is that they are parallel. So I'm going to state that SX is parallel to RX. RX is the first condition. And the second condition you must have for points to be collinear is that a common point must exist. And we have it here. You have the X on both vectors. X is a common point. And they must write out these two things, guys, to prove collinearity. You cannot just write this and stop and say that they are collinear. You have to write out these two things. Once the question says must prove that points are collinear, you have to write out that. Write out that they are parallel and write what the common point is. Because that is when you have collinear points. When you have parallel vectors and a common point. So you have to write out those two things. Then you can draw the conclusion and say, therefore, the points involved, R, S, and X, are indeed collinear. And that's it. You have shown that they are collinear. But okay with that?
Yes, sir.
Yes, sir.
All right. I wanted to redo these questions, all right? I know, I wanted to redo these questions. That is how you cement your understanding of what we're doing. Redo the questions. After the class, I want you to redo these questions. Okay, and I also want to do the question that I sent in the group. If anything, I'll send it again, the same question. So while I'm going through now, I come upon it, I'm going to skip over it. If I come upon it, like I don't remember where I got it from. I got it from a past paper. All right, let's look at 2012 now. More maths equals better maths. Let's look at 2012. All right, let's look at 2012. 2012. So I might have sent these papers in the group, but I don't think these are in the group as yet. We're eventually going to get all the past papers, all of them, at least from 2009, from all the way up to 2022, 2023. We're going to get them at some stage in this program. And you're gonna have to do all of them. So all these questions I'm doing now, you're gonna have to do all these questions in mock exams starting in March. Full exam papers. All these questions I'm doing now, you're gonna have to do them under exam conditions. 2 hours, 40 minutes, the full exam paper. All right, so get yourself familiar with these questions. You're gonna have to do these papers all over again by yourself under exam conditions. All right, so just bear that in mind. Same papers I'll be using for mock exams. This very paper I'll be using for mock exams. I'm not reinventing the wheel. All right, so the same questions you're gonna see come back when you're ready to do your mock exams. All right, so it should be easy for you. All right, so this one knows a calculation one, no diagram. So let's look at it. Let me bring it up here. 2012. Bring it over this side. More maths equals better maths every time. You have to practice, practice, practice till these things become secondary. The more you practice, the better you get at it. All right, look at this one now. Another vectors question. That's part A of this is vectors. Part B is matrices. All right. So we're doing this part E right here. The first part says A, B, and C have position vector this, that, and that. All right. Okay. It says we have to write the vector BA and the vector BC in column form. All right. So that's the first part. Write the vector BA and the vector BC. And these are displacement vector. Remember, if they ask for displacement vector and you have the position vector of the points, then you can use the O times the last minus O times the first formula, or the O times the last minus O times the first method. So since you know the position vector of the B and the position vector of the A, you know both of them. You know the OA and you know the OB. You can use these two to find the BA. O times the last minus O times the first. So this becomes OA minus OB. OA, O times the last minus O times the first. So the OA is this one, 6,2. 6,2. Minus the OB is this one, 3,4. And so you subtract them. 6 minus 3 is 3. 2 minus 4 is negative 2. That is the vector BA. The next part wants a vector BC. BC. So we now want BC. Same thing again. We know the OC and we know the OB. So we can use both of them to find the BC. Once you know the position vectors, the points, you can find the displacement vector between the points using OT on the last minus OT on the first. Position vector on the last minus the position vector on the first. So this becomes OC minus OB. OT on the last minus OT on the first. C is the last and B is the first. So the OC vector is 12, negative 2. Minus the OB vector is 3, 4. So I'm going to subtract 12 minus 3 is 9. Minus 2 and minus 4 is negative 6. And so that's my vector BC. And I can see that this one, look at it now. This one is clearly 3 times this one. This one is 3 times that one. This one larger by 3. So BC right now is 3 times BA. And you can look at it now. If I multiply this one by 3, that's when it becomes equal to this. So this one is 3 times this one. So they are parallel. In addition to that, B is a common point. So right off the bat, without even them telling you, you can realize that the 3 points are on a straight line. So we can draw the conclusion down here. Because right down here now, it says, look what it says. State one geometric relationship between BA and BC. It is that they are parallel. And then now, draw a sketch, show the relative position of A, B, and C. Means that we have to show that they are on a straight line. They are on a straight line. So let's do part 2. The one geometric relationship between them is obtained by showing that they are parallel. Because look, if I multiply this one by 3, let me just do it here in red, in a box. If I multiply this one by 3, I'm going to get 3BA equals 9, negative 6. So this equals 9, negative 6, and this equals 9, negative 6. It means that the 3BA equals the BC. I can say the BC equals 3BA. So we can write that, right? So we can write that BC equals 3BA. So from this, we can answer this. One geometric relationship between the lines, they are parallel right here. Right? So we can answer BC is parallel to BA. That's one relationship between them. If I wanted 2 relationships between them, I would say BC is 3 times the length of BA. Or BC is 3 times BA in length. Because if you take the modulus of both sides, you drop off the arrows and you get BC. The length of BC is 3 times the length of BA. So they wanted a second geometric relationship between the lines. It would be that BC is 3 times BA in length. 3 times BA in length. If they wanted a second one. But the first one there is good enough. They are parallel. Then part 3 now. Part 3 is asking us to make a sketch of the points. So since they gave us these as points, we can literally just act as if we put in them on a graph. You know? Remember, if you know the position vectors, it's like you know the points. Because based on this one, the point A would be 6, 2. The point B would be 3, 4. And the point C would be 12, negative 2. So since this question is saying, draw a sketch to show the relative positions of the points. Let me just act as if we're drawing these points on a graph. So I'll have to do. Sketch those points on a graph to show the positions. That's what I would do. So I'll just make up a sketch. This is only negative 1 and negative 2. So I make up a sketch like this. Like that. Just a little sketch, quick and fast. And I got 2, 4, 6, 8, 10, 12. Because it's go to 12, 2. 12, negative 2. 2, 4, 6, 8, 10, 12. And then I will go negative 2, negative 4, negative 2, negative 4. Then I will go 2, 4, 6. This don't go around 4, so that's fine. 2, 4, 6. Y-axis, x-axis. Then I will put on the points. I put them on in purple. Right? So the first point is 6, 2. So 6, 2 will be right here. That's the point A. Then the point B will be 3, 4. 3 is right here and 4 is up here. So that will be the point B. And then the point C is 12, negative 2. 12, negative 2 is down here. That's about right here. So that will be the point C. And then I would show that they are on a straight line. Draw it so that they're on a straight line. Put it down here so make sure they appear as if they're on a straight line. Like so. Put it here. I mean, you know what I mean. Let's put this here a little bit higher or a little bit more to the right. Like so. And you put them on a straight line. That's what I would do in the exam. Show that they're on a straight line. That's the relative position of the points. That's what I would do in the exam. Because since they give me these position vectors, it's almost like they're giving me coordinates. I would make a sketch and give them that. Then if I want to show the vectors now, because remember now, this point will be your O, the origin O. So I want to put on the vectors as well. Let me zoom it up for you. Then this will be the vector OB. This will be the vector OA. And this will be the vector OC. And that will be a complete, comprehensive diagram. If you give them that, you must get all the marks. Give them everything. I give them the points, I give them the vectors, I give them that they are on a straight line, show the straight line, show that they're on the same straight line. Because that's what this tells me. This is telling me that they are collinear because there is a common point B. Common point B. So the points are collinear. The points are on a straight line, which you can see from that sketch. That's why they ask for this, the relative position of the points A, B, and C. You have to realize that the points are on a straight line. But I go to that?
Yes, sir.
All right, beautiful. All right, more maths equals better maths. Let's go jump on the 2013. 2013. All right, 2013. Let's see. 2013. I want to redo all these questions for me, please. Redo all of them. All right, redo all these questions. All right, 2013. Bring it over here. So I do the recent exams and I do the older exams. You see that they're asking the same kind of stuff. And the more the recent ones are even easier than the long time ones. You can see that. All right, so another vectors question is down here somewhere. Right, another easy question. This one right here, 2030. This one, part E. Part E. All right, let's see. Let's look at this one now. So what I want us to do. So this question says, in the diagram below, not drawn to scale, P and Q are midpoints of OA and O and AB. So Q is the midpoint of this line, and P is the midpoint of this line. All right. It tells us that the vector OA is 2A. That's here. It's 2A. So let's use common sense right away. If this is the midpoint and the whole vector is 2A, tell me now quick and fast. What is the vector from O to P right here?
A.
What is this? A. And what is the vector from P to A right here?
A as well.
A as well. Good. And they tell me now that the vector OB is 2A. This vector up here is 2A. So I'm going to put it on there, right? The vector up here is not 2A, 2B. 2B. All right. So I'm filling out the diagram. Then the question says, express in terms of the A and the B, the small a and the small a, the vector component, the vector AB. Well, this one is easy because you know the portion vector of the A and you know the portion vector of the B. Once you know those, you're going to calculate this easily using O times the last minus O times the first. Let's do it in blue. So this becomes equal to OB minus OA. O times the last minus O times the first equals, the OB is this one, 2B, minus the OA is this one, 2A. That's it. And then I want us to tell them the vector PQ. That is the vector across here, PQ. That's the vector that they want to know. Look at the diagram and tell me how we could go from P to Q. Remember now that we know this vector up here now. We now know this. We know the AB vector. Right? And remember that this point is just halfway up there. So tell me now. Look at the diagram. How could we go from P to Q?
P to A and then from A to Q.
Beautiful. We could go P to Q and then A to Q. If you think of it that way, the vector is easy enough. And the PQ clearly is A, don't it? The PA, sorry, not PQ.
Oh.
Sorry, my mistake. No, my mistake. PA. P to A, you said it right. P to A and then A to Q. You said it right. I wrote the wrong thing. So it's P to A right here and then A to Q, which is correct. All right. And the PA right here is a small a. But what is the AQ equal to? This right here. What is it equal to?
Half of AB.
Half of this. Half of this. So we're going to write this as PA plus half of AB. And let us continue over here. Equal. Let us continue over here. Equal. This thing. Continue over there. So it is now equal to what? Now the PA is just this A right here. Right? And the half of AB is really half of this. So if you're taking a half of that, it becomes B minus A. So it becomes B minus A. This. That's what this becomes, B minus A. And then if you work it out now, it's just going to be equal to B because A minus A, the A is eliminated. So this is just equal to B. So it means that PQ is just equal to B. Let's put on the diagram. The vector from P to Q is simply now just equal to B. I know that from the get going, but don't worry about it. This is just now equal to B, which is basically half of this. So it means that these two sides parallel, and this one is twice as long as this one. You can see that. But this is 2B and this is B, so they're parallel. My question says, state two geometric relationship between OB and PQ. That is this OB and this PQ. Easy, they are parallel, but I want two. Next relationship is that OB is twice as long as PQ. See that? So two relationships is that they are parallel. One is that they are parallel. And the second relationship is that OB is twice or two times PQ in length. In terms of length, it is twice. That's it. OB is two times the length of PQ. Question done. So question and easy, guys. Easy. But okay with that?
Yes, sir.
All right. Good. So right, what is equal to this? All worked out to B. All right, judges. All worked out to B. All worked out. All right. Let's look at 2014. More math equals better math. Let's look at 2014. 2014. That's how you practice. You just go from paper to paper to paper to paper to paper. Can't be too much. Just practice, 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 practice. All right? Paper to paper to paper. Let's go to 2014 paper now. Maybe after I finish these and reach back where I started, I might go back on my sheet, which has some other questions on it. There are past paper questions still, but maybe some older past papers on my sheet. All right. Here's a vectors question right here. Let's bring it to this side. May 2014. All right. So we're looking at this question right here. Part C, all of this. It's a vectors question. All right. Let's look at it. Okay, good. So it says, in the diagram below, the coordinates of P and Q are 2, 4, and 8, 2 respectively. See them here? You can see them on the diagram. All right. It says the line segment joining O00 to P may be written as OP. Remember I told you this in class? See the question there? What is the term used for OP? I told you that there was a question that asks that. This is it. What is the term used for this, guys? I told you in the class that they asked that question. What is the term used for this vector, OP? What is the term for it?
A position vector?
Position vector of P. That's it. Position vector. You can just a position vector, the position vector of P. That's it. I can say position vector of point P. Position vector of P. So I told you, I remember the question, I remember. So that's why I teach the way I teach, you know, because I know every exam question. So I can remember questions, and this was the only time they asked this. Maybe another time. But they don't ask that question frequently. But I remember when it came on the paper for the first time in 2014. I remember. So that's why I know that they ask these things, and that's why I tell you in the class that they ask those things. That's why I teach the way I do, because I know the questions that CXC will ask you. All right. All right, good. Then now, after asking us that, so this is the answer now, guys, for that question. Portion vector of P. That's what this means. That's what that represents. Portion vector of P. Then it says, write each of the following as column vectors in the form. This means as a column vector. The one, the vector OP. So that one is easy because if you know the point, you also know the vector. It has the same values. So this becomes just 2, 4. Same as the coordinates, 2, 4. This one also is easy, but it has the same values as the point. So that is 8, negative 2. 8, 2, sorry, 8, 2. This one is 8, 2. What go to that?
Yes, sir.
Then they
Yes,
want
sir.
PQ. Then they want PQ. And more PQ now can be found using these two. Because if you know the OP and the OQ, you can use them to find the PQ. O times the last minus O times the first. Let's write it. The PQ vector, displacement, is equal to OQ, O times the last, minus O times the first. So it's this one minus this one. Can we just work them? So it becomes 8 minus 2. It's this one, the OQ minus the OP. So in terms of the value, it becomes 8 minus 2, which is 6. And 2 minus 4 is negative 2. If you're not sure, you can check it on the diagram. This is saying to go from P to Q, you go 6 to the right and 2 down. That's what it means. You know? This means 6 to the right and 2 down. 2 down. So we can check it on the diagram if it is correct to go from P to Q, 6 to the right and 2 down. So starting at 2, you go 6 to the right, maybe it's 8. All right? And then now, after you come 6 to the right, and you reach 8, you're going from 4 down to 2. That's why you subtract 2. You go minus 2. So that's correct. Add 6 to this to get this. And then subtract 2 from this to get this. So this answer, we can accept it. 6, negative 2. Remember now, guys, what you get by calculation must match what you get on the graph or in the diagram. All right, next part says, Next part says, OP is equal to RQ. It means that OP and RQ are equal in length and parallel. OP is equal to RQ. It says determine the coordinates of R. Determine the coordinates of R. Now we can do this multiple ways. We can do it from the diagram, or we can calculate it. Because if we want the coordinates of R, what we can do is find the position vector of R first. If you know the position vector of R, then you automatically know the coordinates of R. So I'm going to show you a calculation way to do it. So if you have OP equals RQ, and I really want to find OR, I can split up this side, split it up into position vectors, and write back this, that OP, and when I split up this, it will become OQ, O times the last, minus O times the first, OR. I'm trying to make OR the subject. So it means then I will carry the OR on this side, make it positive, OR equals, carry this OP over this side and subtract it. So we'll get OQ minus OP, right? And so the OQ is the same thing over here saying now. OR minus OP. So it's going to be equal to 6, 2. 6 negative 2 the same way. And this OP minus O times the last minus O times the first is also equal to PQ. So it means that OR is equal to PQ as well. Is that correct? Yeah, OR is equal to PQ. So it means then that R is a point 6 negative 2. Because if OR is this, then R is a point 6 negative 2. That is by calculation. I'll split up this and make OR the subject. But we could do it on the diagram as well. Let's look at the diagram, how we could do it. So they're telling us that OP is equal to RQ. All right. So the question is like it is OP, this vector is equal to a vector from R to Q. So this vector is equal to a vector from R. So it's like this is moved to somewhere here. OP is equal to RQ. So this will be a RQ. So R be somewhere down here. This is going to be equal to this RQ. So R would have to be somewhere down here. Right? So the change in values from O to P is the same change in values after that from R to Q. So the calculation shows me 6 negative 2, you know, which shows me this point down here to be correct. Makes sense that this point down here is 6 negative 2. Because I have to add 2 to reach 8. As I added 2, this point is 0, 0, 0, 0. I have to add 2 to reach 2. And I have to add 4 to reach P. So see, I have to add 4 from negative 2. I have to add 4 to reach this. Well, I think the best way to do it is this over here by calculation, rather than figure it out on the diagram as I'm doing here now. I think the best way to do it is to calculate it by splitting up this vector equation, split it up, and extract the OR out of it. I showed you how to do that in the class. That was on the last slide. I told you about when you have vector equation and you want to extract a position vector out of it, you split it up into position vectors as I did here. And you transpose the one that you want to be the subject. I want to find OR, I transpose it and make it the subject. And then I work it out. And when I find the OR, which is this, it means that this is the point. Hold on, guys, I'll take this call. Give me a second. Hello? What's up? No, actually in class, you know, but let me hear. In Q. Oh, I wrote stuff already. All right. Or you can get you can give me a few. Give you back a call. Yeah, send me the WhatsApp and I'll just do it right after. Cool, no problem. Yeah, man. Cool, yeah. All right, guys. Sorry about that. That was work. All right, something I have to do after class. All right. Somebody okay with this?
Yes,
You have
sir.
to be able to do this calculation, right? Very important that you can do this calculation. So they give you a vector equation like how they give us one here. Let's look at it closely. They give us this vector equation right here. And out of this vector equation, they want to find the coordinates of the point R. If you're going to find the coordinates of the point R, you need to find the OR first. So it's a matter of pulling OR out of this vector equation. The best way to do it is to split it up into position vectors. This is already a position vector, so you're not changing it. But this displacement vector RQ, you split it up into OQ minus OR. And that's how you extract the OR out of it. And then you make the OR the subject. All right, you need to practice doing stuff like this. I'm showing you the easy way to do the mathematics. And I did do a slide on splitting up vector equations to extract position vectors. And see, we get an example here now to do. All right, they don't set it like this very often, but you know, if you have the skill and the practice, then you know, when they set it, you can do it. All right, then this one also state the type of quadrilateral that PQRO is. All right, and we have to justify the answer. It's going to be a parallelogram, you know, especially because we have a diagram. We can see it as I showed you. Move this down, move this out of the way. Remove this. All right, we did say that this is a position vector. Write it down. This is a position vector. Position vector of P. All right, I know I'm saying this is the point down here for R. This is the point R right here. Right here is R, which is 6, -2. And I want us to tell them what kind of parallelogram this is now. This parallelogram. Or that quadrilateral, sorry. I'm saying it's a parallelogram. Okay, look what is happening. OP is equal to RQ. That's these two sides, you know, equal. OP is equal to RQ. Right? And then from here, we establish that OR, this is R, not P, OR, this is OR, this is R, this is R. Then from here, we establish that OR is equal to PQ. That's these two sides now. OR is equal to PQ. And that's a justification, and we have two pairs of equal opposite parallel sides. So to justify my answer for part 3, I'm going to say since, and I did say OR is equal to PQ, since here that they gave me first, OP is equal to RQ, since OP is equal to RQ, and OR is equal to PQ, that's the opposite side. The other sides now. OR is equal to PQ. Those are the opposite sides, you know. So these two opposite sides are equal, right? That's OP and RQ. They are equal and parallel, equal vectors, meaning that they have same length and they are parallel. And then also we got that OR is equal to PQ. This is the OR and this is the PQ. That's the other pair now. So we have two pairs of equal opposite parallel sides. So I can say that is two pairs of equal opposite parallel sides. That's what we have. It therefore means that PQRO, see, PQRO, this point is O, is in fact a parallelogram. PQRO is a parallelogram. So state the type of quadrilateral that it is. It's a parallelogram. Is a parallelogram. Parallelogram. That's what it is, a parallelogram. Why is it a parallelogram? Because it has two pairs of equal opposite parallel sides. How would have equal opposite parallel sides? Because the opposite sides are equal vectors. And equal vectors are parallel and equal in length. That is the reason. Are we good with that? But okay?
Yes, sir.
All right. All right, how long now we're going? About an hour and a half?
Yeah, basically.
All right.
Yeah.
All right, cool. So let's do some more. Let's start 2015. Let's look at 2015. More maths equals better maths. Let's look at 2015. So on Saturday, we're going to be doing the January ones. I'm going to practice more on Saturday. More maths equals better maths. So to practice. Study hard, pass easily. All right. Study hard, pass easily. All right, let's look at this one now. If you redo all these questions, man, watch the video, redo all of them, then vectors won't be a problem for you. I'm telling you. You don't want vectors to be a problem for you because vectors comes with the matrices or transformation question on the paper. You want to get those right. You know, makes sense. You know how to do matrices. In fact, you have to learn how to do everything because you have to do every question on the exam paper. You know, not before when you used to choose. There's no choice thing anymore. You have to do all the questions on the paper. All right, so you have to learn everything. As simple as that. All right, so this one now is a calculation vectors question. They don't give us any diagram, right? They don't give us any diagram. So calculate. Let's look at it. All right, so this question says the position vector of Rs and T, relative to an origin O means, OR, OS, and OT are these. So we can literally just write them down. Right? So it means that OR, which is the first one, is -3, 4. And the second one is OS. That one is 1, 1. And the third one is T, OT. And that one is 5, -2. These three position vectors here. All right. And I want us to calculate the value of the modulus of OR. Which one is OR? The first one, right? This is OR. And this is OS. Let's write them here as well. And this is OT. We want the modulus of OR, which is the length. This one. It's going to be 5 and 3, 4, 5 triangle. So we'll learn about the Pythagorean triple. But this is going to be equal to the square root of this value squared plus this value squared, which is the 3 squared and the 4 squared. That's going to work out to be 5 units. With the trigonometry, we'll learn about the 3, 4, 5 Pythagorean triple. All right, so I know the answer is 5. If you want to work it out, it's going to be 9, it's going to be 16. 9 and 16 is 25. They're going to do the square root of 25, which is 5. All right, but I can tell you it is 5 by looking at the numbers. It's a 3, 4, 5 Pythagorean triple, which is 5 units. Next part says express in the form xy, which is means column vector, the vector rs and the vector st. So since again we know the position vectors, no problem. Once you know the position vectors, you're good. This becomes os minus or, easy stuff. O times the last minus O times the first. So doing the S1 minus the R1. So doing this one minus this one. Careful negative sign. So we're doing the 1, 1, which is the OS, minus the OR, which is -3, 4. And so this becomes equal to, let's put it here, 1 minus a -3 is really 1 plus 3, which is 4. And 1 minus 4 is -3. That is your RS. Then you want ST, same thing again. You know, portion vector of the S, and portion vector of the T, then use O times the last one, it's O times the first. OT minus OS. Once you know the portion vectors of the points, you're good to go. The OT is this one, 5 minus 2. 5 minus 2 is subtracting OS. And OS is the 1, 1 vector. 1, 1. 1, 1. Let's write that vector. Subtracting 1, 1. So that works out to 5 minus 1 is 4. Minus 2 and minus 1. Right, minus 2 and minus 1 is negative 3. But I see these two vectors equal enough. So it means that these two vectors equal. In addition to being equal, you have a common point. So it means that S is the midpoint between them. So you're going R to S and then S to T is the same vector. It means that S is the midpoint. So that they're on a straight line. You have R here so, T here so, and S here so. Because a vector here and a vector here equal. All right, let's see the want us to draw any conclusion. We can see that based on the values. RS equals ST. So S is the midpoint between them. This is a common point. Let's see. It says using the results of combining vector of B2, justify that RS is parallel to ST and that is a straight line. See, that's what it is. All right. So I'm going to write it here. I'm going to write since the vector RS is equal to the vector RT, ST, which was the, what was it again? It was the 4 minus 3. What am equal to 4 minus 3? If them equal, it means that them parallel. And then you have a common point. Right? So you're going to write that. So you're going to say, okay, 1. They are equal vectors and so they are parallel. So I'm going to write equal vectors here. If them equal, it means that them parallel. So I'm going to write RS is parallel to ST. That's the first thing. Secondly, S is a common point. S is a common point. I'm stating that they are equal vectors. And because they are equal vectors, you know, so them parallel, them also equal in length. But in addition to that, we have S as a common point. Therefore, they are also collinear. R ST is a straight line. The points are collinear. Is a straight line. Meaning collinear points. And that's it. I've shown that they are parallel because they are equal. And then they also have a common point, which makes the points collinear, meaning they are on a straight line. And that's it. Easy question. Easy question. But I go to that.
Yes, sir.
All right. Let's go now and look at 2016. 2016. Let's just throw in this kitchen sink. 2016. On Saturday, I'm going to focus on the January papers. On Saturday. The Saturday session, we'll just do some January papers. All right? Since we exhausted June ones now, we'll do the January ones. And remember, guys, very important. Go and redo the questions. We're going to have a class activity Sunday, Monday. And then we're going to do the classwork Wednesday, Thursday. And we're moving on to a new topic after that. Right? We're moving on to trigonometry after that. We want to solidify these things. All right. So like we can work on the paper. Just make that size smaller. So this one gives us these points again, A, B, and C. Give us position vectors OA, OB, and OC. I like when I give me position vectors, and okay, I can't find anything. It says express in the form XY, I want the vector AB first. I have the position vector of A and the position vector of B, so I can use the position vectors to find them. It's OB minus OA, which is equal to this one minus this one. I can just work them out now. This one minus this one. So it is 6 minus 2 is 4. 1 minus a negative 2. 1 minus a negative 2 becomes 1 plus 2 is 3. But understand that?
Yes, sir.
AB is 4, 3. Good. And I want AC next. O times the last minus O times the first. OC minus OA. OC minus OA equals. So now I'm doing this one minus this one. Subtract. So it's 10 minus 2 is 8. And 4 minus a negative 2 becomes 4 plus 2 is 6. And right off the bat, I can see that this one is twice that one. 2 times relationship. So they are parallel. Right? So I have to multiply this one by 2 to be equal to that. So I can see that AC is 2 times AB. And also you can see that A is a common point. So you have parallel vectors are common point. The 3 points are collinear again. You can see it, points are collinear. It says, hence determine whether A, B, and C are collinear. Yes, by this. And says, since, and just copy this down. Oh, sorry. Let's move this right here. I'm going to write that first. Based on these that we have, based on these, right? Multiply this one by 2, it becomes 2AB becomes equal to what AC is. So AC is 2 times AB. So I'm going to write that. There it's collinear. I'm going to write 1. AC is parallel to AB. Second thing, A is a common point. Therefore, the points involved, A, B, and C are indeed collinear on a straight line. They fall on a straight line. But okay with that?
Yes, sir.
Yes.
Questions easy like cheese. All right. Let's look at 27. I want to do at least one question from my sheet, before we finish, right? That's what time is it? All right, so we'll finish. Let's look at 2017 next. I think we had stopped at 2017 yesterday. 2017. So this question is easy. A very easy topic. Just have to know that is about how you go from point to point. All right, so we had stopped at this one last time. So let's do it now. All right. The second I help make it easy because it is easy. Something is easy, just easy. Can't do anything about the fact that it is easy. Let's do this one. All right. So this one again gives us the vector OP and the vector OQ, right? And they give us some information here now. It says PR is 3 times OP. So this side has 3 OPs in it. Yeah, put it on there. Right. This here has 3 OPs in it. This has 3 OPs in it. 3 OPs. So it means that the whole thing is 4 OPs. OP and 3 OP makes 4 OP. So I can write over here that OR is 4 OPs. What do you say that? Make sense?
Yes, sir.
Good. All right. And a similar thing happening down here because this QS is 3 OQs. So right here has 3 OQs in it. And so the whole thing is 4 OQ. I'm going to write over here again. So OS. And let me write this down here. Let me write this down here. Because OR is 4 OPs. I can write that OR is 4 times this, which is 1612. 4 times this. And then the other one is OS is 4 OQs. That's 4 OQs in it. And so OS then is 4 times this, which becomes 20. All right, so we have that information. So the more OS, have it here, so let's write it back. They have it there. So let's write it here. OS is all of this is 4 OQs, which becomes 20. 4 times the OQ. This is the OQ. Next thing I want is PQ. Now we know the portion vector of P. We know the portion vector of Q. So we're going to use OQ minus OP. O times the last minus O times the first. The OQ is 50 and 43. 50 minus 43. 50 minus 43. So it becomes equal to 1 negative 3. We go from P to Q. Take a diagram, see if it makes sense. We go from P to Q. You go 1 negative 3. 1 negative 3. All right, that's it. That's PQ. What is the one? The one RS. A portion vector of R and a portion vector of S. Work it out here. This is R. All right, and I want RS. So remember we worked out. This becomes OS minus OR. But I would leave this on my exam paper and let's see if we're working out right here. That the OR is actually 1612. 1612 and the OS is 20. So 1612 minus 20. 1612 minus 20. So it becomes negative 412. Go from R to S. Negative 412. That can't be right. That cannot be right. Let's see it again. I have it the wrong way around. RS. That cannot be right. RS is OS minus OR. Or OS is 20. I have them wrong way around. 20 minus 1612. I've the wrong number. I've them the wrong way around. That's why. It's 20 minus 1612. 20. That is the OS minus OR is 1612. So it becomes 4 negative 12. No, it makes sense. Go from R to S, go 4 to the right and 12 down. See? Go from R to S. Go 4 to the right and 12 down. Makes sense now. That's why I like diagram questions, you know. I told you in the class, you can check your answer to see if it makes sense. So I made a mistake, diagram tell me that it is wrong. Then I want two relations between PQ and RS. That's why I know what PQ and RS is. So PQ was, what does it tell you? PQ was 1 negative 3 and RS is 4 negative 12. Now if I multiply this one by 4 for it to be equal to that, you know. But times this one by 4 is going to be equal to that. I'm going to get 4 PQ equals the 4 negative 12. So it means the RS is 4 PQ. All right, that's yes or no. RS is 4 PQ. And put this to the side. This was just for our information. Just over here. It's smaller. right? But based on those, it's obvious that the bigger one RS is 4 times the smaller one PQ. So we have RS is 4 times PQ. This means that the parallel. So one relationship is at the parallel, right? RS is parallel to PQ. And then RS is 4 times as long as PQ. That is better. It's like RQ2, so it's over PQ. Right? And then the RS now is on this relationship. I can see it on the diagram as well. RS, this line, RS is 4 times as long as this one. So the parallel, but RS is longer by 4 times. So RS is 4 times PQ in length. Second relationship. RS is 4 times PQ in length. 4 times the length of PQ. RS is 4 times the length of PQ. Done. Nice little question, quick and fast, nice and easy. Always stay, very good.
Yes,
Yes.
sir.
All right. Remember, now, guys. You have to go and work the questions over by yourself. All right, let me bring up one more question for the night now. More maths equals better maths, 7 o'clock. We started about 5:30, so still only working for about an hour and a half. We really check it out, right? So let us go and do a question. One more question from the homework booklet. Where is it? Bam, 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 bam. All right, I wanted us to just finish off this question over here. This one over here. All of that, all right? Let's do this. Let's do this. Let's call it a night. Let's do this, let's do this. All right. All right, so doing this part first, part A. Right here. Points A and B have position vector. This is A and this is B, yeah? And it says the point G lies on AB such that AG is 1/3 of AB. So they give us a position vector of A, this one position vector of B, then they give us this vector equation. All right. Then I want us to find AB and AG. All right, let's see what we can work out with these. Now, if G is on the line, AB, right? Then it's like you have the line AB like this, and G such that AG is 1/3. So G is right here. So this is 1 part, 2 parts, because AG is 1/3. So like a divided line, let's do it again. Like a divided line in 3 equal parts, like so. And the G is right here. AG is 1/3 of the whole line. All right, that's it. So it means then that if that is the case, it means that the vector AG is also 1/3 of the vector AB. So we can write that from this from this. We can write that the vector AG is 1/3 of the vector AB. All right, I will do the position vector of A and the position vector of B. All right, so let's go now. I want us to find the vector AB first. It's quite easy. Let's do it in purple or in blue. All right, so AB becomes OB minus OA. The OB is 4, 2 over here, so. Minus the OA is negative 2, 5 right here. So we wrote that out. 4 minus a negative 2 becomes 4 plus 2 is 6. 2 minus 5 is negative 3. That's the vector AB right here. Then it wants AG. Well, we have AG is 1/3 of AB, so simple, right? It's 1/3. So AG is 1/3 of the AB. That's what this says. That's what they gave us here. And so it becomes 1/3 of the 6 negative 3. That's what the AG is. And so the AG then, vector AG becomes 1/3 of 6 is 2. 1/3 of negative 1, negative 3 is 1. Negative 1, sorry. That's the vector AG. Then they want the position vector of G. Easy. We have this. I have to split it up. So part 2. If you have the AG equals this and you want to find OG, you split this. So from this, we're going to split this side and get OG minus OA equals 2, negative 1. Cover the OA over this side. You get OG equals 2, negative 1 plus OA. I'm just going to write what OA is beside it with a different color. The OA really is this, negative 2, 5. So the OG is really 2 and minus 2 is 0. Minus 1 and 5 is 4. Same as 5 minus 1 is 4. That is my vector OG right there. That's my vector OG right there, guys. All right, can test if it makes sense, you know, by recalculating AG. So calculate back AG. It will be OG minus OA, which will be 0, 4, minus back OA, which was minus 2, 5. Gonna get 2 minus 1. Yes, 2 minus 1 AG. 2 minus 1. It is correct. I just checking out. I gotta double check. All right, that is it. Then I come to this part here now, which is the part that I really want to do. The diagram. Right here. Let's call it a night after this, for sure. All right. So they give us this diagram. And it shares diagram below, not drawn to scale. It says B is the midpoint of OX. This is the midpoint of this line. All right, good. All right, so whatever this vector is from here to here, this vector here is the same thing. All right. Then it says C is the midpoint of AB right here. C is the midpoint of that line as well. All right, good. Then it says D is such that OD is 2 times DA. OD is 2 times DA. So it's like you can take OD and fit it into the OD. You can take DA, sorry. You can take this DA and fit it into OD 2 times. So like this has 2 parts and this has 1 part. So the line is in a ratio 2 to 1. You can see it. Right? That's what I'm saying now. OD has 2 DAs in it. So you have DA right here. So the OD right here, it has 2 DAs in it. 1, 2. So this part of the line has 2 parts and this has 1 part. So it means that right here is 2/3 of OA of the whole line. And right here is 1/3 of OA. But I can appreciate that.
Yes.
But that's good. So if this has 2 parts and this has 1 part, and the total part is 3A, the vector overall is 3A. All of this is 3A. It means then that this vector right here is A, And this vector right here is 2a. Make sense?
Yes.
And then OB is B. So from here to here is B. Let's put it on. But this must be B as well. Because it told us that this and this equal. All them tells us are equal. Because it tells us that this is the midpoint of the whole thing. So if the vector from here to here is B, then on the same line, the vector from here to here is B. Because it's the same line, but on same length. Those are my vector components on the diagram. I just need to calculate with those now. Then I'm on the vector AB. Now, since I know the position vector of A and the position vector of B, I can just calculate this one. Let's do it in blue. O times the last minus O times the first. This becomes OB minus OA. Make the marker like a small, like a thinner. Let's go a little bit thinner. So this becomes OB minus OA. The OB is B, the OA is 3A. All right, we'll also look at the diagram and say, how do I go from A to B? I go minus 3A plus B. We'll get it that way as well. All right, and we take it same answer. Then I want the vector AC. Now AC right here is just half of AB. We have AB already. So AC is just half of AB. Easy stuff, right? So AC is just half of the AB, which means that half of this and half of that. So you get half B minus, and half of this now becomes 3 over 2. 3 over 2 A. Then I want DC next. D to C. Somebody tell me I'm going to get DC. Look at the diagram and tell me. I'm going to do it over here, DC. Look at the diagram and tell me how I'm going to get DC.
From D to A, and then from A to C.
D to A, and then A to C. All right, give me the values now. The DA is what?
A.
Small a, and the AC is what? Just work it out here, right?
Yes, sir.
It is half B minus 3 over 2A. Consolidate this A and this A. Remember now, let's write this one. This is our diameter of 2. Let's write this as 2 over 2. So this is the only value of the B, and I'm going to write that back first. Half B. And then 2 minus 3 is negative 1. So get minus a half A. That's what the DC is. Does it make sense? Let's check if it makes sense. So I'm going half B, which is out here, then minus a half A. See, this will be half B, and this coming this way. Let's try properly so you can see it. This and this answer is saying go half B. Saying go half B, which is to come out here, and then go minus half B about here, and then minus. This will be minus half A. But this is A now. This is what a little piece of A. This. Right? And then this now will be half B. So the answer like it makes sense. Answer makes sense. Just on this diagram. All right, so that answer is good for DC. Then the one DX. Tell me now, how do I go from D to X? Easy, come on, cut the diagram. DX.
So from D to O, and then from O to X.
Okay, D to O. Well, this one kind of easy because we have the position vector, don't it?
Yes, sir.
But the position vectors, you know, the position vector of D is 2D, and the position vector of X is 2B. Let's write them out. OD, based on the diagram, is 2A, and OX is 2B. So therefore, we want to find dx. It is OX minus OD. So it's this one minus this one. So it simply becomes 2b minus 2a. That is the vector dx. All right, good. So I found all these four pieces, right? And down here now, them says state two geometric relationship between dx and dc. It's gonna be at the parallel, and how long one is more than the next. So comparing dx and dc, these two. dc is this, and dx is that. That looks like a 4 times relationship. Let's set it up. So for part 2, we are comparing dx and dc. So the dx, as we have it, is 2b minus 2a, and the dc, or the space, let's carry this over some more. The dc is here, half b minus half a, half b minus half a. Now, I say get rid of fractions, right? Well, look here, you can realize that if I want this to become equal to that, I need to multiply it by 4. So sometimes I can do that now. Let's look at what will make them equal. If I multiply this by 4, then this side becomes equal to that side. So you're going to see that this becomes 4dc equals, multiply this by 4 becomes 2b. Multiply this by 4 becomes minus 2a. And so this now is equal to this. Because the two of them equal the same, 2b minus 2a. So I'm going to do that. And so therefore, now equate dx is equal to 4dc. So we have two things happening here. We have a common point. So to answer the first part, which is two relationships between the lines, we're going to say dc or dx is parallel to dc. That's the first relationship between the lines. And then based on this number, you can see that dx is 4 times the length of dc. Right? dx is all of this length here, so. And dc is just a piece. So dx is 4 times the length of dc. So I'm going to write that. dx is 4 times dc in length. That's the second relationship of the lines. Four times dc in length. All right. And then now, this part down here now, so I must state one geometric relationship between the points. So I'm going to say now, then parallel now. And I'm also going to say that D is a common point. So because I have this parallel vectors and a common point, I can draw the conclusion. So therefore, the points are collinear. D, C, and X are collinear. That's the one relationship between the points. The points are collinear. So we ask between relationship between lines. I'm gonna say all the lines parallel. I'm gonna say how long one is more than the next one. If they ask for a relationship between lines. CXC like to ask for two relationship between lines. And they like to ask for one relationship between points. The one relationship between points is that they are collinear. Always that is the answer. We have to show it. And the two relationship between lines is one, that they are parallel. And the second one has to do with the length. How long one is more than the next one, the length. That's why these are the two things that you give. When you give me the two relationships between lines. When you give me one relationship between points, it's always that they are collinear. It could be that they're not collinear, but it always has relationship between points is whether they are collinear or not. But I've all the questions when I ask for relationship between points, it is always that the points are collinear, always. And when I ask for relationship between lines, it is always that the lines are parallel. And the second relationship now is just based on the fact that, for example, here, dx is 4 times dc. You know, so the length of dx is 4 times the length of dc. So those are two relationships that you can give for lines. And that is that for today. But okay?
Yeah.
All right. So you know how it is. You're going to go for me. You're going to redo all these questions and watch over the video. And you're going to do the question that I sent in the group. The question that I sent in the group, a vectors question. Know that we have practiced all of these questions. I need to see answers coming through. So I'm going to repost those questions and I need to see your answers. You have to work the questions. If you ever get it wrong, no problem. You learn from a mistake. Don't worry about it. Just do the question. Send me your answer. Let me see a chain of thought. Let me see a line of thinking. So if anything, when you come to class, I'll know what to emphasize, what to correct. Right? I see if there's anything that you're misunderstanding. But I can know those when I see your work. All right, everybody. So please and thank you. Do those questions. Do the questions, 2 questions. Do them and send your answers to me. And also redo all these examples. Watch over the video if necessary. The video is always good to watch over because you know it's a second chance to look at what we did. It says reinforcement. All right, guys, that's it. So see you all Sunday and Monday. We're gonna do a class activity, easy class activity, Sunday and Monday, and then Wednesday and Thursday it's gonna be classwork. And then after that, we're going into trigs. All right, guys. Bye. Good night. Bye, everybody.
Bye, sir.
All righty.
Hi, sir. Good morning.
All right. All right.